Hello, this is Kilon, and I'm back from Easter vacations, and really I'm excited to show you some of the progress I've been making with Ephestos. So let's get started. If you want to get Ephestos and try it yourself, it's still in very infant state, so there's not many things that can do, and it's not very impressive. But we have to bear in mind that I'm now building the foundations of the project. And so most of the time is actually spent in the architecture rather than actually creating something that is visual useful for the user. But I'm going to link you to this YouTube video with this page, which has a small description of what Ephestos is going to be, and not what Ephestos really is. At the moment, Ephestos is just a very basic GUI. This is only the part that I call Morpheas. So you can download it from here as a zip, as a tar, GSG, if you have Linux, and of course macOS. Zip usually is the format that most operation systems recognize, even Windows. And of course Vue on GitHub for those of you that want to browse the source code online and really see what happens inside Ephestos. So let's see Ephestos. I have created a small Python script to trigger Blender, and let's start Blender. Okay. If you want to install Ephestos, it's very simple. You're going to download the zip file, and inside that zip file, you're going to find a folder called Ephestos. You just drag and drop that folder, only that folder called Ephestos, to your add-ons folder, and then you do this. You go to File. One second to move this around. File, user preferences, and you go to add-ons, and you go to development, because Ephestos essentially is an ID for Python and a visual programming language that sits on top of Python. And so it's going to be in this category from now on. And you find here Ephestos, if you have copy-pasted in the right folder, Ephestos, the golden age, and you enable that. And then down here, you're going to find an Ephestos button. This now only works for the 3D view, a viewport, but it's my intention to work for the entire, for any window here, so you can use Ephestos anywhere you want. So if you open Ephestos, you will see these three boxes. These boxes are called morphs. The great thing about morphs is that they are very flexible. They have a very deep architecture, which on one side is complicated in the sense that you can do many different things with them, but on the other side it's also very simple because it follows a natural idea of the concept of GUI. So what I've managed to do from now on is actually only move, excuse me, there's a small delay, oops, yeah, there's a small delay because of the video, but this must be much more smooth for you. Also, this is the development version, so I'm actually printing a lot of statements here to actually see how the events are handled. So this also causes some delay, but this delay is going to be fixed, and there will be no delay at all. And this should be run a lot faster for you that are trying this at home. So as you can see, those morphs can be moved around, they can be dragged around. There are GUI elements. I'm going to offer a designer that is going to create a lot more complicated visual elements than just simple colored boxes. The great thing about this part of Ephestos called Morpheus, which is actually the GUI of Ephestos, is that it sits on top of your GUI. If you see here, you see that there's full interactivity with the rest of the Blender GUI. There's just a small delay because I'm recording this video, but it should be as fast as using the GUI without Ephestos. And of course you see there's also a delay here. You can use Blender GUI as you used your GUI before. You can left click and do all the processing. All the key events are handled the same. Your shortcut doesn't change. The only thing that changes is the escape key, which I have mapped to exit Ephestos. You can right click to select things like here, and of course move them around. and of course at the same time you still can move your morphs around. So the intention here is to create a GUI for Blender that sits on top of the Blender GUI. It doesn't disrupt or creates any obstacle for the Blender GUI. You can still use the Blender GUI and still, and this GUI, of course, the Morpheas GUI, which will be the GUI for Ephestos, is going to be a lot more flexible and more capable to use it for creating your custom GUIs. For example, if you want to create custom buttons, or you may want to create images here that you want to see alongside your 3D, or maybe you want to create animations that you can see. You can design your own GUI without having the restriction you have now here in this. And the most important thing, you will not have to code the GUI. Everything will happen as I'm doing it right here in a user level, and so the user will be able to design their own GUIs, something that they cannot do without doing some kind of coding, Python coding for the Blender GUI as it is. And of course, it's going to be a lot more flexible. Now, for those of you who are users and don't want to actually see anything else, that's all about it. I'm going to talk now about the architecture of Morpheus itself, and this is actually going to talk about the code behind you can use. And so without any ado, let's exit Ephestos with escape key, and let's go here to Exeter and see the code. Let me reload it. As you can see, the design of Morpheus is actually very simple, but yet it's very deep. We have actually several classes here. This is the point class, which defines a point. You define a point very simply with entering coordinates of x and y axis. Morpheus is, as it is actually a strictly two-dimensional GUI, as is the Blender GUI as well. But there's no restriction per se to make Morpheus also a 3D GUI. So it may be also possible to have GUI elements that move inside the viewport, or they seem that they move inside the viewport. For example, they may be able to attach on a cube and interact with the cube, and you can see the GUI be further back on top of your cube than actually seeing an overlay on the screen. It still is going to be an overlay, but because we are using the BGL, it's actually mapping the OpenGL functions, and it gives us the ability to create 3D graphics because it's OpenGL, of course. But of course, the rendering is happening on top of the viewport, so it's going to be an illusion, not an actual. It's not going to be actual geometry, a Blender geometry, as you're used to with cubes and other things in Blender. So back to the code. You have the point, which is just a point you're going to create. You have a representation here that prints. You see this at, we use at emails. It actually shows you the x-axis and y-axis. You can do several logical things with point. We will be expected to do with numbers or with strings. You can, for example, compare for two different points to see if they are equal. You can compare them to see if they're not equal. This actually are not. You don't call these functions by name as they are here. For you that do know a bit of Python coding, you know that you call them just by using here the question mark, the exclamation mark and the equal sign, or when you want to be equal, double equal, as you do with any other Python type. So it behaves exactly like any other Python type. That's a great thing about it. You can see if it's less than, greater than. You can round it, as you can round any number. You can max it or min it, as you can do also in other numbers. Sorry, it's a bit slow. You can be floor division, true division, which is exactly the same here. You do with other types like here. This is or this. You do with numbers. So you can treat points like numbers in a sense, because even though they're something, for example, that you cannot do with the Blender types, because Blender creates its own types. It's called properties. All these are properties, and they don't have a full Python interaction. They don't have a full Python identity in a sense that you cannot just compare them that easily, or create negatives and subtract them and add them together and multiply them. But even though I might be mistaken, you may be able to do some form of interaction with them. But here we try to make it as interactive as possible and as natural as possible. And then there's a round rectangle, which is the square, which is just a square, as like the morphs that I've shown you earlier. And you see here that we define also a lot of different functions. You see that I haven't actually documented the rectangle class yet, but I'm going to fully document everything, so you'll never lost. And the reason why I'm showing you this is because besides the user interface, you can already use this for building your own GUIs for BGL, for those that want to not go down the route of Blender GUI and use Morpheus. You can use Morpheus as a library, as a Python library, and you can use it to create your own add-ons with more flexible GUIs. And you see here that we have a lot of functions that give us a lot of information. For anyone out there, you may recognize this function as getters. They actually provide you information about the rectangle you're building. Where's the bottom? What's the bottom center? What's the bottom left? What's the bounding box? What's the center of the rectangle? What are the corners? The extent is actually the area that the rectangle occupies: left, right, width, top, center, top, left. Things that you can actually understand by yourself. And then we have merge, expand, intersect, and contains point. You see that we have a lot of different functions to suit everything. So you don't have just a simple rectangle. You have something that it has a lot of flexibility and interactivity in a user level and in the developer level. So you can subtract rectangles, add rectangles together, and this kind of stuff. The node is just a class before the morph. It offers some very basic parenting abilities, like, for example, the same parenting you have used to do with objects here. So because the power of Morpheus and Morphic GUI is that it can embed multiple morphs in a single morph. So you can have many morphs grouped under a single morph, and you can create some very complicated GUIs, but you never lost because everything belongs somewhere. You have a hierarchy of objects like you do in object-oriented programming, and besides the object themselves, which are the morph class, you have also the parenting we have here. We have children, we have leaves, we have parents, we have siblings, and what we mainly use are actually the children. So every morph can have several children, and those children are actually embedded inside the morph we are browsing. So this is actually the class that defines the morph. We have the init class here that defines some very functions. It inherits a lot of these, as we say, parenting functions from the node class. So we have here the node inheritance. And you can see here there's several functions. Some of the functions are actually remaining from the Morphic GUI, because this is actually, I'm using PyMorphic, which is a port of Morphic GUI that comes from Smalltalk and from Squeak and Scratch, which are IDs for Smalltalk, and they're very, very good at it. And so this is actually what I'm creating here. It's not actually my own idea. Morphix actually it's a 40 years old. So it's a very old GUI that is still very flexible and very capable, that I want to implement inside Blender. And you see here we have things that we expect to find, like width, height, full bounce. Full bounce is also the full extent of the full area of the morph. We can set the position, so we can relocate our morphs beside using the mouse. Of course, you can call, and this is actually what I'm doing. I'm calling this function for relocating the morphs. We have set center, which I'm set width, and we have set height, set extent, move by. And move by usually is you move something. This is actually the function that draws the morph. You can see here we use ignore this, ignore also this, which is the color, and this is actually the only thing we do. We use the glRectI function, which actually creates only a rectable, an open GL rectable, rectangle, sorry. And so it's very simple. And we have other draw function as well, which I haven't used yet. I'm not so sure if I'm going to keep them or throw them away, because as I said, I want also to go with my own direction on this. But you see, we can have double visibility, so you can hide. You have a hide and GUI element, something that you cannot do here, for example. You cannot hide GUIs. Of course, you can collapse them, but you cannot hide this on only this or only this, but you can do that with morphs. And we have add, we have morph add, we have several other functions. And this is actually the type of events you won't find in other properties in Blender, which is mouse click left, mouse down. When you handles mouse over means that when your mouse passes over the morph, Morpheas actually creates this event, which is the mouse over. So, for example, if you want to create something like the Apple iPhoto, when you mouse over a small thumbnail, you see your photos passing by. You can do also that. So you can do some very complicated and very nice things with morphs you couldn't do with Blender GUI. So we have mouse enter, also the same. Enter dragging is usually when you enter a drag area inside the morph. Leave dragging when you leave this area. Mouse move, of course, the mouse move we all know, when something is moving, the mouse on top of a morph. And this is some other areas, choose color, etc., which are not implemented yet. Not all the functions here are implemented, and you cannot. I'm not using all of them, and I'm not even sure if I'm going to keep all of them. It will depend how useful it is. We have frame, which is sit on top of a morph. Again, full bound, full drawn on, and this kind of stuff. Frame is actually one step before the world. What the world is the canvas, in a sense. World is a canvas, and on top of that canvas, it sits. There are actually the morphs that are the UI elements. And as I said, morph can be anything. Can be a button, can be a slider, can be a picture, can be animation, can be anything you want. And this is actually the kind of flexibility I'm trying to offer here. Because word inherits from frame, and because frame inherits from morph, a word object is actually a morph with some functions added to it. So it's not something you want to recreate. It's morphs that actually you can actually use it as a morph and shares the same principle as a morph. And we have, of course, some extra principle. For example, the world is not draggable like any morph. You cannot drag it around because it's a canvas. We keep it still. But of course, you want to enable that. You can have a world that you can drag around like a canvas, that you can drag around for drawing your graphics. And we have several. The mouse cursor. And what happens when you move a morph? You add the morph that you move in the hand morph, which is a mouse cursor. You add it as a children, and it's attached to it, and it inherits from it, and you move around. And when the movement stops, it's separated as it's deleted as children, and it again exists as a morph separately. Of course, it always exists as a morph separately, but it's no longer a child of hand morph. So the hand morph represents your mouse, and of course, I have created all the functions here to process a Blender event, and this is actually why we can have full interactivity with the Blender GUI, because I try to keep all the GUI elements. When an event actually passes from Blender to Morpheas and Ephestos, what it does is actually filter the event. So it actually decides whether it's actually an event that concerns Ephestos. And an event concerns Ephestos when it's on top, when the mouse is on top, or when a morph is actually selected at the point. And so it knows that you're trying to do something with a morph. If the mouse is not over a morph, then it knows that you don't try to use Morpheus or Ephestos, and it passes the event directly to Blender, so you can do the things that you are normally do with Blender. So this is all about Ephestos. I have nothing more to say. You can contact me with inside the thread. I'm looking for other developers to help me. And if you have any suggestion and any question, and you want something changed or if a feature be implemented, please drop me a message in the usual thread, and I'm trying to do my best to actually implement this feature. Have a nice day and goodbye.